Okay, so what we will be doing today, we have two worksheets. One is algebra review and one is college math placement. So I think we'll do the algebra review first, algebra review 5. We had two homework problems, three that I gave you for homework, right? Can you see the screen?
Yeah,
Task math, algebra review. You
yeah,
got my message that our last day is Monday.
yeah,
Yeah, I just got that from Miss Beckles today.
yeah.
I told her that's what was on the
I was on
original
my phone, but
schedule.
I see when it come up. Yeah.
Yeah, okay. Because she says now our last day is Monday. All right. So let's look at number 2. Maureen, read number 2.
Number 2 is 6 more than 7 times a number is 34. Find the number.
Now, what does 6 more mean? What in math terms?
The multiply.
6 more?
Yeah.
No,
Add.
6 add, that's right.
No.
Now, what does 7 times a number in math terms? What
7
operation?
times.
Addition, subtraction, multiplication, division. Which one?
7 times multiplication.
That's right. Very good. Now, when you see is, what term is that? When something is,
Is equal.
that's it. Very good, Maureen. You remember. So when you see is 34, that means equal the 34.
4.
So
Yeah.
since we know 6 more is adding 6, 7 times a number is multiplying by 7, and is 34, that means that expression is equal to 34. Okay, so since we broke it down, let's just say let
Mhm.
n
Yeah, and
equal the number. Okay, now if n is equal to number, how do I write 6 more than n?
is his number. 6 times
Well, now we said 6 more was adding, right?
6 plus
Yes, because 6 more,
plus 7.
okay, 6 more means addition. Okay, so how do we write 6 more? Just 6 more. How do I write that? N is the number. How do I write 6 more?
6
6,
times.
well, 6, well, no, 6 more will be 6 added to something, but it's
6 added
added
to
7 times a number. So how do I write 7 times a number?
7x.
Well, I'm using N now, right?
Or 7n.
Times, yeah, times, let's just put this, okay, times means multiplication. Okay, so if the number is n, I would have what? 7n. That's 7 times a number. And what am I doing with that 7n? What am I adding to it?
34.
No,
6.
it says 6 more. So that means I'm adding 6, right? So that's
Uh,
plus 6. Now, what is that equal to?
7 plus 6 is 13.
No, 6 more than 7 times a number
That's
is
42.
what?
Multiply, right?
No, 6 more than 7 times a number. 7 times the number is 7n. 6 more is adding 6, and is equal. So what is that equal to?
34.
34. That's right. All right. So we have translated our words into the math. 6 more, add 6, 7 times a number, multiply 7 times a number we're calling n is equal 34, and we say equal 34. Okay, Maureen, is that expression clear to you now?
Yeah.
Okay, 6 more, add 6 to 7 times a number and set it equal to 34 because we say is 34. Now, what do we do first? We want to solve for n. What do you do first?
Okay, the subtract
Yes, you subtract what?
6 from both sides.
That's it. Very good, because 6 is being added. So you want to subtract 6 from both sides. So let's just copy this. Okay. And we'll say subtract 6 from both sides. Okay. So let's subtract 6. On the left side, we'd have minus, that's for subtraction. And on the right side, minus 6. Now, what do we get on the left side when we do that, Maureen? What would my left side be right here? 7n plus 6 minus.
7n. You get 7n, right?
Right?
7n plus.
What's a plus 6 and a minus 6?
0.
0. Anytime you add the same and subtract, add and subtract the same number or variable number combination, you get 0. So, and what's 34 minus 6? Subtract 6 from 34. What do you get?
18. Not 28.
Oh, 28. That's right. Not the math.
And
So
then you divide and get 70. The 7 is 0. 7 is 20 is 4.
7 divided by 7 is 1.
Yeah. But
Yeah, you're right. You're right. You do divide. You divide both sides by 7. Or you could just say here, only one number times 7 will give you 28, and that's 4. So you could use mental math and get the answer as 4. Okay. So, or like you said, you get n equal 28 divided by 7, and that's equal to 4. Okay, small n, just to be consistent. So what is the answer?
Yeah.
Answer is A.
I had that number, but don't ask me how I get it out.
Oh, you had A?
Yeah, but I know I know how I do mine, but I
Okay.
didn't do mine like this.
Okay, you can figure it out without writing it out like this, but you've got to keep in mind that, well, some people take the number choices and put, like 7 times 7 is 49, and if you add 6 to it, you don't get 34, so you know it can't be B, right? And the other numbers are too big. All right, so the answer is A. Okay, let's look at number 2. Well, that was number 2. Number 3. Now, Maureen, did you do number 3? That's scientific notation.
I guess number 3.
You guessed? Okay.
Yeah.
Now, when you say quotient, what operation are you talking about? Addition, subtraction, division, multiplication?
Subtraction.
No. Quotient.
I guess okay, answer, but I don't know if it's right.
Quotient, Quient, is the result of division. So when you divide something, what you get is a quotient. So you taking the 9.2 times 10 to the 6. Let's just put that here. And we dividing that.
Divided by 2.3.
That's right. Divide that by. So let's just underline this. And we dividing that by 2.3 times 10 to the second. So what do you do to the exponent when you divide? Maureen, what do you do to the exponents when you divide?
I ain't got a clue.
You subtract the exponents, remember?
Oh, yeah.
You
So this
subtract.
2 from 6 is 4, right?
That's right. So, and 9.2 divided by 2.3 gives you what?
I think 4.
That's right, gives you 4. So you get equal 4. 9.2 divided by 2.3 is 4. And subtract the exponents, you get what?
4. 2 from 6 is 4. Which
That's
will
it.
be 10 over 4.
No, you
4
mean
10,
into the 4th power.
yeah.
Okay, so this would be into the 4th power.
4.
So what
Which is
answer would that be? D.
D.
Okay, so you got that. Very good.
Yeah.
Answer D.
What's that? I figure I didn't do.
What, number 4?
I didn't do number 4.
Oh,
I would get him.
Maureen, ordered
I would,
pairs. You can do number 4. Remember I said,
I would get mixed up in my with these all these different dashes and things.
okay, these are ordered pairs like X, Y, X, Y,
Oh
X,
yeah.
Y. They're ordered pairs. Now, you can't have duplicate X. Now, remember, ordered pairs, these are ordered pairs.
It can be D.
Or
Can we see?
X, Y. Ordered pairs. So that means the first numbers are X and the second one is a Y. Now, you can't have duplicate X values. All right, so the one that's not a function is the one that has duplicate X values. So which one has duplicate X values?
Which one have duplicate X? But
Yes.
A.
You see, what are the duplicates?
Okay, listen. X, Y, X, Y, X, Y.
Which one is duplicate, Maureen?
Yeah.
You said A. What is duplicate? What X value is duplicated in A? Tell me what are the X values in A?
2.
Okay.
Minus 2.
Okay. What else?
1 and minus 1.
Okay. And what else? One more. Right here.
4.
No. 0.
0. 0.
The X values come first, remember? So 2, 1, 0, minus 1, minus 2. Now, what are your X values in B? Tell me that.
Is 2.
Okay.
1.
Okay.
0.
Mm-hmm.
Minus 1. Minus 2.
No duplicates, right? They're all different.
Mm-hmm.
Now, what about C? What are your X values?
2. 1. 0. 1. 2.
Are there any duplicates?
Yeah, 1 and 1.
1 and 1, and also what? 2 and 2.
2.
Okay, so that means they are duplicates, so it can't be a function. So what's the answer?
D,
Which one?
D.
You see duplicates in D? No, you just told me C had 1 and
Uh,
1. That's duplicate X values.
mhm.
And it also has 2 here and 2 here. Those are duplicate X values. So that means C has duplicate X values. So the answer has to be what? What's the answer?
I don't know.
No, you just told me the duplicates.
Duplicate is A, B,
The
and
duplicates
D.
are no, the duplicate values for X are in choice C, because C has a 2 here
Mhm.
and it has
And
a
it
2
got a
here.
two
That's
there, yeah.
duplicates, right? And it
Uh,
has a 1 here and a 1
and
here.
one there.
That's duplicate. So it
Uh,
says which is not a function. So if it's
oh,
not a function, that means they are
it's
duplicate
C.
X values. That's C. Because D has, they're all different. 2,
Uh,
1, 0, -1, -2. All the X values are different.
uh,
Got it? So you look at your ordered pairs, and the one that comes first is the X value.
uh-huh.
All right. And the second one is the Y value. So you don't worry about the Y values. They can be duplicates, but that's not the ones. It's the X value, the input. They cannot be duplicated. If they are, then the ordered pair is ordered set of ordered pairs don't represent a function. And that only happens in C, where you have 2 repeated and 1 repeated. Got it?
Okay.
Okay. If they're all different, then it's a function. That's how you can tell a function
I
when
see.
you have ordered pairs. Okay, so the answer is C. So let's just put the C here. Answer C. Okay.
Mhm.
Is that clear, Maureen, with ordered
Yes.
pairs? Okay.
Yeah.
Now, let's look at number 5. Do you know how to factor of, of actually factor a radical? Okay, Maureen, if I gave you the number 36,
Mhm.
give me 2 numbers you can multiply to give 36.
Six sixes
That's right, 6 times 6. What else?
and 9.
What?
No, not 9. 6. This is 36.
6 times 6. What other 2 numbers multiply to give you 36?
Let's see. 2.
2 times what?
8. 2 times 18.
That's right. Anything else?
2 times 18. 6 times 6 is 36.
Right.
Uh,
What are the 2? This is called factoring. When you take the numbers, the number, and break it down into the numbers that can be multiplied to give you back that number. Give me another set.
okay.
You gave me 2. Just give me one more.
Let's see. 6 is 36. 2 18 is 36.
2 more numbers I can multiply and get 36.
9 and 4.
That's it. 9 and 4. Those are factors of 36, right? But just
Yeah.
like you can have a factor of 30 of a number, you can have a factor of a radical. All right.
Mm.
So let's just take this. Okay. Okay. Now, just like I had 36 and you gave me factors, you can take this radical square root of 72, and there are factors that multiply to give you square root of 72, and they are a square root times a square root. Now 72, what are some factors of square root of 72?
Okay.
Now,
6
since
and 12.
6 and 12, that's true. Now, I want you to think of a square root factors where you have a 2, because see, you have a 2 right here, right? Square root of 2. So think of factors where one radical is square root of 2. Now, what would the other factor be? What number time? What factor radical times square root of 2 gives you square root of 72?
6 and 12.
No, no. Okay, what I'm saying is, let me just put this. Okay. Now this is square root of 2, right?
Mm-hmm.
Now I want you to tell me the other radical that I can multiply by square root of 2 and get square root of 72.
Oh,
Or if I ask you this, 72 factors are 2 times another factor. What is that other factor?
okay.
What number times 2 gives 72?
36.
36. That's it. Okay, so that means I can say square root of 72 is square root of 36 times the square root of 2. So just like we took the number and we wrote factors, you can take the radical and break it down into radical factors. Got it?
Um,
So a square root of 72 is square root of 36 times square root of 2, just like 72 is 36 times 2.
yeah.
Okay. The same way you did with a number, you can do with a radical. So the same way you can say 72 equal 36 times 2, you can say square root of 72 is square root of 36 times square root of 2. Okay, Maureen, what's the square root of 36?
6.
6. That's right. So let's just copy that. The square root of 36 is 6. So that becomes 6 times the square root of 2. Okay, so if I have square root of 72 minus 3 times square root of 2, but my square root of 72 is 6 times the square root of 2. So let's just copy this here. That's the problem we were given originally. Okay, and that would be square root of 72, which is 6.
6.
That's right. So I'll take the 6 times the square root of 2 and put it here. Okay. So let's see. So this would be, let me put this here. Okay. So the square root of 72 is 6 times square root of 2. So I substituted in the square root of 72 minus 3 times square root of 2 would be now, let me just copy this so you can see the flow of it here. Let's copy what we were given originally, this expression. So you can see your answer, right? So the square root of 72 minus 3 times square root of 2. Square root of 72 is 6 times the square root of 2. What's 6 times the square root of 2 minus 3 times the square root of 2? Now remember, for a radical, you can subtract the coefficients
So
just like we.
the answer would be C.
That's right. Very good, Maureen. You subtract the coefficient 3 from 6, and you get 3, and then square root of 2. That's right. That's your answer. So remember, you have a
Another two more.
coefficient in front of the radical, just like you have coefficients in front of variables.
I
So
had that there, but I didn't know if it was right. I put
yeah,
three and two,
well,
but yeah, I didn't know
you
if it was right.
you
I,
got it right. Very good, Maureen. Yep. But just remember, just like you factor numbers, you can factor radicals.
mm,
Okay. So if you had square root, just to test you out, let me give you another radical and you tell me what it is. Okay. Suppose I had, let's see, square root of, I'm gonna put another one here, see if you can break it down for me. Okay. Okay, square root of, let's see. I want to give one that's got a perfect square root. Uh, let's see, 50, 56. Oh, let's see if I try 9. Okay, let's take square root of 81. No, I don't want that one. That one has a perfect square root. Square root of, I won't want, it's not a perfect square root, but it has a number that has a perfect square root. Square root of 48. Now, Maureen, I want you to give me two square roots that multiply to give you square root of 48. And one of them will have a perfect square root.
6,
6 and what?
6 and 8.
Neither one have perfect square root. Remember I said one of the
Or 1.
radicals has a perfect square root. So what would it
Uh,
be? What two numbers, think of two numbers multiply to give 48. You said 6
okay.
and 8. I
2
said
by 24.
neither
2
one
and
have a
24.
perfect, neither one have a perfect square root.
Oh, you want one of the perfect square root.
I want two numbers,
Uh,
one of which has a perfect square root.
perfect square root.
So you've given me two factors that are good, but neither of the factors you gave me had perfect square roots. So give me two more factors.
Okay, hold it. 40.
Two numbers multiply to give 48.
That ain't got a square root neither. 24 don't have a square root.
24 doesn't have a square root. 2 doesn't have a square root.
I
6
know.
doesn't have a square root. 8 doesn't have a square root.
How about 3 and 16?
Very good, Maureen. 3 and 16. So if I put square root, if I put 16 and multiply that by, and you said 3, right? 3.
Mm,
But square root of 16 has a perfect square root. So what is the
okay.
square root of 16?
4.
So, okay, so that would be 4. And this would be square root of 3. Okay, so now you have the coefficient of your square root of 3, which is a 4. So
All
you
right.
gave me 16 and 3, and that's what? Square root of 16 is a 4, and then square root of 3. Okay, you could have given me 4 and 12, because 4 has a square root of 2, right?
Mm-hmm.
And so you could have given me, let me just copy this here. You could have, there's another possibility. Let's put that here. And this is equal to, so you could have given me 4, right?
Mm-hmm.
Because 4 times 12 is 48. So 4 times the square root of 12. And
5.
what's the square root of 4?
2.
That's right. It's 2. So that would be,
Maybe 2 and square root 12.
that's right. Very good. 2 times the square root of 12. So this would be 12.
Uh,
Right. Okay.
but-
So when you breaking these down, you really most times looking for one of the factors that has a perfect square root, because you like combining them. Like here, you had the square root of 2, 3 times the square root of 2 subtracted from this. So that means
uh,
the 72 has to be broken down into 2 factors, one of which would give you the square root value
2.
of 2, and that number is 4, right? Okay. Questions?
No.
Okay. So just remember, you can factor radicals just like you can factor numbers. Okay. Now, Maureen, number six can be done mental math, or it could be done ratio proportion. Did you do number six?
Yeah.
Did you do number six?
Yeah.
What did you get?
Yeah.
What answer did you get?
225.
That's it. 225. How would you do it mental math?
I multiply 150 by 20 and then divide it by 30. But I do mine in ratio. I always call it.
Ratio and proportion?
Yeah.
You can use ratio. Okay. Use
Yeah.
ratio proportion or mental math. So you have 2 ways to do it. Now, how did you do yours ratio proportion?
I put 150, which is the calories,
150. Okay, calories. All right.
and I put on the 150, 20.
150 calories, and then you put the time, which was what, 20 minutes?
Mhm.
20 minutes. And
And
you set that equal to what?
equals the come up to and then I put before come out anything. Oh, you want to know how much that come out to the hour?
No, no. Well, see, a ratio proportion has 2 ratios set equal.
Yeah.
So you put 150 calories over 20 minutes. What was on the right side of your ratio proportion?
Then I put an X, which is a unknown,
Okay, X, the unknown calories, and that's
and put
over what?
30.
That's right, over 30 minutes. Okay, so this would be 30 minutes. All right. Then what did you do?
I multiply the 150 by 30 and get out 4,500.
Okay, so you cross multiply.
Multiply, yeah.
So 30 times, okay, so you multiply what? 20 times X, right? 20
Mhm.
X equal 30 times 150, which is equal to
Five.
4500. And then what you did?
I then divide both sides by 20.
Okay, divide both sides by 20. Okay, and that would give you X equal 4500 divided by 20. And you got the 225. And that's answer what, D?
D.
Now, how could you do it mental math? Now, the shortcut mental math, how would you do it?
But mathematics, I did it like this. I multiply 150 by 30 and then divide it by 20.
No, that's not the mental math. The mental math is okay. 150 calories for 10 minutes. I'm sorry, for 20 minutes.
20.
20
Yeah.
minutes, yeah. For 20 minutes is half that for 10 minutes, right? 75 calories for 10 minutes. Okay, that's just mathematics. Half of the 150 is 75, half of the 20 is 10, right? So
Mhm.
30 minutes is 3
Mhm.
times 75, and that's equal to 225. That's the mental math.
Oh,
Yeah, you just take the 150 calories for 20 minutes, divide it in half, that's 75 calories for 10 minutes. So 30 minutes is 3 times 10. So 3 times 75 is
wow.
225
Oh,
calories.
oh.
All right. So that you could have done it mental math or ratio, right? You see how the mental math works? Because
Yeah.
you have some nice little numbers here. This 20 and 10, like the factors are 10, right? So if you know 150 calories for 20 minutes, you know you can burn half the number of calories in half the number of minutes, which is 10. So if you have 30 divided by 10 is 3, and just multiply 3 by that 75 and you get 225.
Okay.
All right.
Mhm.
So that's the other way of doing it. That's why I say math is always more than one way of solving the problem. All right, Maureen, did you do number 7?
No, I didn't do 7, 8. I do 9, but I love it, right?
Okay,
I didn't do 7 and 8.
okay. Well, let's look
I
at
did
number 7. You can actually do number 7 because 7, they're asking you to do what? To put it in the slope
line.
intercept format. Okay, put equation, because that's what it's asking you to do. Put equation in slope intercept format, which is what? Y. And what's that equal to, Maureen? Y equal what?
Y equals to 2.
No, what's the slope intercept format? Y equal mx.
M X plus B.
That's right. Plus b, where m is the slope, m is the slope. And what is y? And what is b? And b is what? The y-intercept, the value of y when x is 0. And slope is the rate of change. Okay, so we really saying take this equation and put it in the y equal mx plus b format. So let's just copy that here. And Maureen, tell me, how do I get it to look like my slope intercept formula? In other words, how do I get y equals something, not 2y? What would I do?
Okay, hold on.
What would I do first to just get y on the left side?
I don't even know.
No, 2
Uh,
times y is a multiplication. So the opposite of multiplication is what?
division.
That's right. So you divide both sides by what, Maureen?
By 2.
That's it. By 2, because that's what's being multiplied by y. So you're
Mhm.
going to divide both sides by 2. So let's just take this equation. Divide both sides by 2. Let's do that. Okay, the left side, we want to divide by 2. So that would be, and then the right side by 2. Okay. So on the left side, we have divided by 2 and the right side. So let's just do that. So that would be 2, and on the right, 2. Now, what's 2y divided by 2?
1 by
1y or just y. That's right. So on the left side, we just get y, right? So that's y equal, and that's the little y, just to keep things consistent. So when we say x minus 4 over 2, that's really saying x over 2, because you divide in both, okay, minus 4. Okay, so this would be a 2 here. Let's just, so we really, both of them is 2. Okay, okay, so that's 2. Yeah, but we don't need the underline here. Okay, and we don't need the, let's just move this over. And we don't need the underline except under the X and under the 4. Okay. So let's take that out. Okay, and put the 2 here. Because what this means, x minus 4 over 2 is saying x divided by 2 and minus 4 divided by 2. Okay, so let's just put that a little closer. All right. Now, Maureen, can you see what the slope is? So y equal
equal
what? One. This is like a 1 over 2, so that's like 1/2, right? 1 over 2 is 1/2. 1/2 x minus 2. That's the y-intercept. So y equal mx plus b. So what's the slope, Maureen? What is the m here?
half.
Coefficient. That's right. Very good. The coefficient of the x is the m. Okay, so slope is equal to 1/2. That's the number in front of our x. The coefficient of the x is the slope. So that is 1/2. And what answer would that be?
C. No, B.
B, that's right, because C is a negative. Okay, so answer is B. So what you're really doing is taking the equation they gave us and put it in the y equal mx plus b format. So the m is 1/2, the b is a minus 2. All right.
Mhm.
Questions, Maureen? Any questions?
No.
Okay, so when you given an equation that's not in that format and you're trying to get the
Okay.
slope, you want to get the coefficient of the X, the number in front of the X, and we figured that out. That's 1/2. So 1/2 is the slope. If they had asked you for the y-intercept, then you would have had a -2 as the y-intercept. Okay, Maureen, let's look at number 8.
Given A equals to B plus 2C. B equals to 3C. What is the average number? What is the average number?
What is the average of numbers
Numbers A,
A,
B, and
B,
C.
and C? Now,
I
how
never
would,
do this hard.
yeah, okay. You've done this, Maureen, but normally you do it with numbers. Let me just give you some numbers here, and then I want you to do the same for this, okay? Given numbers 1, let's say 1, 2, and 5. What is the average of these numbers? Okay, all right, I gave you 3 numbers, 1, 2, and 5.
Mhm.
Let's see, 1, 2, and let's make that 6 because I don't want a fraction. Okay, how would you find the average of these 3 numbers, Maureen? What would you do?
Okay, let's see. Average. You add them
That's right, and do what?
and then divide
Divide by what?
the 3 numbers. Really 3.
That's it. You add the numbers, divide by 3. Very good. So your average would be equal to 1 plus 2 plus 6 divided by 1. You said 3, right? Because
Yeah.
there are 3 numbers. So we underline that, and we put our 3. And what would that be equal to?
9.
Right. So that would be equal to 9 divided by 3. And 9 divided by 3 is what?
3.
That's right. And so that would be 9 divided by 3. And that would be equal to 3. So equal 3. Okay. So the only difference in the and this problem that I just gave you and the other one is that they gave you variables instead of numbers. Okay. So all right. So numbers, you did this exactly right. You add up the 3 numbers, and since they're 3, and divide by the number of numbers here, or number of items here, which is 1, 2, 6, and you got 3. Now we are saying, what is the average of the numbers A, B, and C? So you would have A plus B plus C. Okay, let's put A plus B plus C divided by what?
3.
That's it. Very good. Divided by 3. Okay, so now instead of numbers, we've got variables, but they're all different. So what we want to do is get them get just one variable. Okay. And how do we do that? We want to get just one variable. Now, they gave us, let's see, they gave us A equal B plus C and B equal 3C. So let's just copy that here. So they gave us A equals B plus 2C and B equals 3C. So we can substitute these values into this equation. Okay, so substitute these values in equation. And I'll just give this a number here. Okay, so we want to substitute these values in equation number 1. What would that look like, Maureen?
Which numbers?
I want to substitute these values. So for A, I want to put B plus 2C. And for B, I want to put 3C. So take this equation. This is equation.
Okay.
Okay. This is equation 1, right? Which is here. So tell me what I get when I substitute these values.
Okay.
So what is A?
A is equals to B.
A equal what? No, it's right here.
B plus 2C.
That's right. B plus 2C. Let me just move this over. B plus 2C. And B equals 3C. Okay.
Mm-hmm.
And this is little a. Okay. So if I substitute for A, B plus 2C, then this becomes B
Mm-hmm.
plus 2C.
Plus.
And what is B? That's plus B. What is B? B is 3C, right? So B is going to be plus 3C, right? 3C. And then we have plus C. Okay, so A is B plus 2C. B is 3C. So this would be B is 3C and B is 3C. And then C. So that would be 3B plus 2C. B is what? 3C.
Well, that'd be 5C.
So no. So then for B, I put my 3C right here, right? 3C. Yeah, substitute B plus 2C for A, but then I put the 3C for the B. So I have 3C plus 2C plus 3C plus C, and this is divided by what? 3.
Okay.
Okay, so that's divided by 3, right? Okay, now I've got everything in terms of C. So what's that equal to, Maureen? Add up all your C's. What do you get?
C.
What's C? How many C's do you have?
3, 6, 8 C's, 9 C's.
3 plus 2 plus 3 plus 1
Yeah,
equal what?
9.
That's right. So I have 9C divided by 3. And what's that equal to?
3.
That's, it's equal to 1?
3 is 9, 3 C.
That's right, 3C. So 9C divided by 3.
3 C.
That's right. That's equal to 3C. Equal 3C. So what's the answer?
D.
D. Answer D. So you want to get, well, once you say by average is A plus B plus C over 3. Now you want to get this as one variable. So that's why you use what they gave you, B plus 2C for A, but B is 3C. So for B, we put our 3C, all right, and C, B is 3C, okay, and then plus C. Now we've got everything in terms of C, and we can get our answer.
Okay.
So you had to use those equations. They gave you A that has C in it, and it also has B, but they gave you B that has C in it. So you can end up with just a one variable. All right. But remember, this is exactly like you did with the numbers, except you got variables instead of numbers.
Okay.
Add up the variables, divide by 3, except you need to get the variables as one variable. Okay. So the key is to get this as one variable. Any questions on that, Maureen? I know this is different from what you've done.
I understand.
Normally you work with numbers, or if you work with variables, they may just give you one variable. Okay, but here they gave you 3 different variables, but you had to use substitution to get it to one variable. Okay.
Yeah.
Yeah, when you look at this, because I'll send you this session, you'll see that when you substitute what the value, the variables, the equalities they gave you for the variables, which is A equal B plus 2C and B equal 3C, you can reduce this down to one variable, C. Okay. And the hint that you got to get it to C is because all your choices are in C, right? All your choices in C. That means you gotta reduce this equation to one variable divided by 3. One set of variables. Okay. All right, let's look at. Oh, you said you did number 9. Tell me how you did number 9.
I just did a number.
Okay. It tells you subtracted from the square.
Mm-hmm.
Result is, so tell me what to write, Maureen. How do you translate the words into the math? What did you let the number be equal to? Let number equal, what variable did you use?
I say N.
You use n. Okay, let number equal n. Okay. Now, 36 subtracted from the square of a number. How did you write that?
This sounds bad.
How did you write that in math terms? How do you write 36 subtracted from the square of a number? Where the number's n.
The number N would be 5 times the number. No.
The number n would be squared, n times n, right?
That,
What answer did you get, Maureen?
I get C, but I don't know if I get right.
Oh, you got C? Okay.
Well,
It's not C. Okay.
let's see.
Now, this, if you say numbers n, that would be n. Okay, and that would be squared, right? So this is squared. Let's put little n. So 36 is subtracted from this, right?
Mm-hmm.
So let's just, so that means n square, you subtract 36, right?
Uh-huh.
36 is subtracted from the square of a number. The result is, so that's equal. What is that equal to, Maureen? How would I write 5 times the number?
5
Yeah, 5 what?
X.
Well, you use n, right?
Uh-huh.
So it'd be 5n. If your number was x, it would be 5x.
Yeah,
But
5
we said
times
let number equal
X.
n. So
Uh-huh.
square of the numbers n to the second power, subtract
Mm.
36 from it, that's minus 36. 5 times the number is 5 multiplied by the number.
Okay.
Okay.
Well,
Now, what would we do with this now? Subtract the minus n from both sides, because what we're going to end up with is what we call a quadratic equation. All right.
uh,
So
uh,
let's say subtract 5n
and from both sides.
That's right, from both sides. Okay, so let's just do that. Subtract the 5n from both sides. Copy that. Subtract the 5n on the left. Okay, minus 5n and the 5n on the right. Okay, so I have n squared minus 36 minus 5n equal 5n minus 5n. So now let's just put this in the quadratic format. Okay. So this would be minus 5n, okay, minus 36. And what's 5n minus 5n, Maureen?
0.
That's right, this is 0. So now we have our quadratic. This is a quadratic equation. And a quadratic equation has 2 values, right? Now, it's in the a square minus b, or we could say x squared minus b x minus c, where c is a constant. Now, what 2 numbers can we multiply, get 36, and add to get minus 5? So
We could get 2 numbers for 36.
we want to factor the quadratic.
Over 9 and 4.
9 and 4, okay. 9 and 4 multiply to give you 36, and they could add to give you the 5, right? So let's just put here, okay, n, and you said 9 and 4, okay. So let's just put n, and Okay, so you said 9. I'll put 9 here and 4. Now, which one is positive? Which one is negative?
Negative. The 4 is negative.
The 4 is negative. Well, remember when you add, you want to get a -5. So if you want to add and get a -5, your bigger number has to be negative, right?
Wait, 9.
Yes, because a -9 and a +4 gives you a -5. So
5.
that's how you can determine which one is negative, because the 9 has to be negative because this is a -5, right? So
Huh.
this would be a -9 and a +5. And of course, that's equals 0. As we say, the quadratic is equal to 0. The factors will be equal to 0. Okay.
Mhm.
So what is the positive number?
4.
Well, remember now, if these two are equal to 0, if the multiplication, the factor is 0, then you set them also equal to 0. So that means n minus 9 equal 0 and n plus 4 equal 0. These are this in all cases little n. All right. So if n minus 9 equals 0, then this means n equal plus 9. Okay, because you add 9 to both sides. But if
Mhm.
n plus 4 is equal 0, you're going to subtract the 4. So this one, n equal minus 4. But they ask you, what is the positive solution? So what's the answer, Maureen? Which one is positive?
9.
That's right. So the positive solution is the 9. So answer
Yeah.
A. Right. Answer A. What is the positive solution? Now, when you get these factors and you say they multiply to give you 0, that means each one of these factors is also 0. So when you set it to 0, then the one that gives you the positive value, that would be the answer. So add the 9 to both sides, n is plus 9. Subtract the 4 from both sides, n is a -4. So the positive solution is 9. Questions?
Uh,
All right, so that's, how did you get 3, Maureen?
I got 3.
How did you get
I tell you, you only guess now. But
Oh,
it won't.
you guessed it. Okay. Well, this is a quadratic. When you
Uh,
set it, when you set up what they gave you, square of the number, subtract 36 equal 5 times the number. Right away, you can see that's got to be a quadratic because you got a square of a number, right? And you've got a number with the coefficient, and you've got a constant, and that's what makes up a quadratic. A squared plus b, well, a squared, or you can say x squared plus bx plus c equals 0. That's the format of the quadratic. Did you try number 10?
no. I didn't get chance to do it.
Okay. All right, Maureen, read number 10. Let's figure it out.
Okay. I have club charge in one time. What this word in
Initiation.
initiation fees and a monthly fees. John paid $100 for 2 months of membership. However, Peter paid 200 for 6 months of membership. How much will Sylvia pay for 1 year membership?
Okay, so look like you're gonna have some equations there with two unknowns, right? So we know that the total that they pay is initiation initiation fee and a monthly fee. Okay, so the health club charge, so the charge includes initiation fee and monthly charge. So you pay an initiation fee and a monthly charge. Now, what we want to figure out is what is the initiation fee and what is the monthly charge. All right.
Mhm.
Now, we have two unknowns here, right?
Mhm.
We have two unknowns here. Let's just say let X
Excuse me.
equal initiation fee. Okay. And let Y equal, and we're calling that the monthly fee. At Y equal the monthly fee. Okay, so we have two unknowns here. We don't know what the initiation fee, and we don't know what the monthly fee is, right?
Mhm.
Okay, so what can we say about what John pays? John pays what?
$100 for two
Okay,
months.
right. So we can say John, let's just say John. Okay. Now John paid what? $100. So the charge that he paid includes a monthly fee and an initiation fee. So John's charge was $100
That
equal,
was 2 months.
what did he pay? He paid an initiation fee of X plus he paid 2 months of membership. So that would be 2 times whatever the monthly fee was. So that's what John equation would look like. He paid $100 and that $100 included an initiation fee and 2 months of membership. That's why we have the
Wow.
2 here times the monthly fee. So now if I gave you John, Maureen, now you tell me what would Peter's be.
Peter would be
Let me just put Peter here. Okay, so John,
would be 200.
right, okay, so Peter would be 200. That's right, 200. And what would
Plus X
200 would be equal to what?
6 months.
So he paid 6 times the monthly fee. So this would be a 6, right? Okay. So John's $100 is broken up into initiation fee of X plus 2 months of membership, 2 times his monthly fee. Peter's is 200 equals X plus 6Y, initiation fee plus 6 months. Now, how can we solve? These are what we call simultaneous equations, right?
Mhm.
How can we solve these, Maureen? What do we say about this? How do you think we could solve these two equations?
Okay, let's see. Could we add?
No, because you got an X and a Y. You got two unknowns. So we want to eliminate one of the unknowns. So we just have one unknown. So we want to use elimination method. Now, which one do you want to use? You want to use you want to get it down to just the X left or the Y left?
I take the X.
You take the X, okay. So, well, let's see. Let's take, so if I multiply this equation by 3, I can get 6y, then I can subtract and eliminate the y, right? So let me just put 1. Call that equation 1. And this I'll call equation 2. Okay, so multiply, because I want to get this one to be 6y, then I can subtract and eliminate the y, right? So using the elimination method, let's say multiply equation 1, multiply equation 1 by 3. Because if I multiply by 3, Maureen, I'll have 3 times 2 is 6y, and then I can subtract, right? So let me just take this equation. That's equation 1. And let's multiply that whole equation by 3. Okay. So multiply the whole equation by 3. So I'll put it in parentheses, 3 parentheses. So that means I'm multiplying the whole equation. So what's 3 times 100?
300.
Okay, 3 times 100 would be 300. And that would be equal to, what's 3 times x?
3x.
3x, very good, okay. What's 3 times 6y?
18.
3 times 2?
Oh, I thought you said 6. 3 times 2 is 6.
6y, okay, so that's 6y, okay. Now I can subtract equation 2 from this equation, right? Okay, subtract, I'll just put here, subtract equation 2. Because now I can eliminate the y, because I can take this equation and subtract it, okay? So let me take this equation, 200 equal x plus 6y. Okay, now we'll subtract this, okay? What's 200 from 300, Maureen?
100.
That's right. So I subtract here, I get 100. What's 3x minus 1x?
Yes, minus 1x is minus
3
what?
minus 1. No, 3 minus
4.
1. No, 3
4.
minus 1.
3.
No, 3 minus 1.
3 minus 1 is 2.
That's right. So because this is a 1x,
Yeah.
right? So that would be equal to 2x. And then 6y minus 6y is 0. So if 100 is equal to 2x, what is x equal to? What's x equal to, Maureen?
Hold on.
100. Well, that's a math actually, 2. And that's equal to 50.
50. You call it dividing, right?
That's right. Divide both sides by 2, or mental math, only one number times 2 to give you 100, and that's 50, right? So X is 50, so that means $50 is the initiation fee, right?
Mhm.
Okay. Now, if $50 is the initiation fee, we can actually find the monthly fee because we can take either of our equations and solve for y, right? We could take the first one or the second one. Okay. Okay. Use equation 1 to solve for y. And y is the monthly fee, right?
Mhm.
Okay, so let me take equation 1, 100, x plus 2y. And now we know what x is, right, Maureen? What is x? Substitute 150 for x. So we will substitute 50 for x. So this will be 100 equal 50 plus 2y, right? Now we can find y. How would we find y, Maureen?
Okay.
How would we
It's
find y?
100. You divide.
No, what would we do first? We want to get the 100 with the 50, right?
Uh,
Let me bring that down. Okay, so we want to subtract 50 from both sides, right? Subtract. You want to do that first before you divide. Subtract 50 from both sides. So let's just take this equation, subtract 50 from it. So 100 minus 50 on the left side. And 50 on the right side. So what do we get on the left side, Maureen? What's 100 minus 50?
50.
That's right, 50. And 50 minus 50 is 0, so that's just
Um,
equal to 2y. So what is y equal? 2
2 y.
times. So what is y equal? What do you multiply by 2 to get 50?
25.
That's right. So y equal 50 divided by 2 equal 25. And that's the monthly fee. Now, our question was to find what?
Sylvia.
Okay, let's go back up here. So our question, how much would Sylvia pay for a year? Okay, so let's just put here Sylvia's total for the year. All right. So
Mm-hmm.
Sylvia's total for the year would be what? How could we find Sylvia's total for the year? Well, we know her total is going to be the initiation fee plus her monthly fee, right?
Mm-hmm.
So a total will be initiation fee plus monthly
Mm-hmm.
uh, fee total. But what is the initiation fee? We found that is $50, right? 50
Yeah.
and $25 a month. 12 months has, I mean, 12 months in a year. So that would be 12
12
times
times
25, right?
25. Mm-hmm.
Yeah. So what's her total? What's 12 times 25?
12 5 is 60. 12 2 is 24. 6 is 30.
12 times 25?
Yeah, 12 5 is 60. 12 2 is 24. And 6 is 30. 300.
300. So that'll be 50 plus 300, and that would be $350. What choice was that? What choice was number 10? What was the choices? Okay, let's go back up to the top. Oh, this one didn't have.
100 choices.
Yeah, we had to just come up with a total. So $350, that would be Sylvia's total. Total. To the health club. Okay, so we had to find two things here. Okay. We had to find the initiation fee, and we had to find what's the cost per month. And once we found that, we could find Sylvia's total for the year because she's going 12 months. She pays a one-time initiation fee of $50 for 12 months at 25 a month, $300, and 300 plus 50, 350 is her total.
Mm-hmm.
But we had to first set up the equations based on what the other two people paid, John and Peter, right? So we use John and Peter totals to get the monthly fee and the initiation fee. So for Sylvia, we plug in the initiation fee and the total fee per month. And that gives us the total that she pays. Okay, Maureen, that's the end of the review. And I think our other question, our other sheet was on, let's see, I want to do a new share. The other sheet was on college placement. Can you see the screen, college placement?
Yeah.
Math, number, and quantity.
Yeah.
I think we did this one before, Maureen. You
Let's
remember
see.
how we did number one? We did it before.
Let's see. I work at the bookstore and the restaurant. It 28 days period. I work 1/4 of the days at the bookstore. And did work 1/14th of a day on the mandated days. No, we didn't do this.
Yeah, we did it. Well, I know
Mm-mm.
I had it on another sheet. But anyway, let's figure it out. She works two places. She works at a books. Carol works at two places. She works at a bookstore and a restaurant.
Right. Yeah.
And we're looking at a 28-day period. So let's just put here, okay, 1/4 days
At the bookstore.
at the bookstore. Okay.
And did not work.
Okay. 1/14 of the days did not work. Okay.
On the remaining days,
Okay.
Carol worked at a restaurant.
Remaining days. Remaining days at the restaurant.
How many days did she work at the restaurant during 28 days
So it's a,
period?
yeah, it's a 28. Let me just, okay. So it's a 28-day period. Okay. So if it's a 28-day period, we can take the fraction times the number of days to get the days she worked. Okay. So it's a 28-day period. So how many days did she work at the bookstore? Maureen, how many days?
1/4.
Well, 1/4, 1/4 uh, times 28 equal days worked at the bookstore. Okay, so what's that equal to? What's 1/4 times 28?
1/4.
Yeah, 1/4 times 28 equal what?
Okay, hold on.
28 divided by 4.
7.
That's right. So 7 days she worked at the bookstore. Okay. Now 1/14 of the days she didn't work. So 1/14 times 28. And what's that equal to?
1/14 times 28.
That's the days she did not work. Days did not work. What is that equal to, Maureen? What's 1/4 times 28?
Okay.
1/14, I'm sorry. What's 1/14 times 28? 28 divided by 14.
2.
That's right, 2. So 2 days she did not work, right? So,
Mhm.
so total equal 7 plus 2 equal
9.
9. So remaining days, okay, so remaining days
Oh,
are worked at the bookstore. Okay, so if she had 28 total days and we've accounted for 9 of the days, how many days did she work at the bookstore?
19.
That's it. Very good, Maureen. That means, okay, 28 minus 9 equal 19 days worked at the bookstore. So you had to find the days she worked at the restaurant, the days she did not work, whatever's left, or the days worked at the bookstore. So that would be what answer?
B.
That's right, answer B. Okay. So you had to use the fractions. 1/4 times the total, 28, 7 days at the bookstore. She did not work 2 days, 1/14 of 28. That's 9 days out of the 28. So the remaining 28 minus 9 equal 19. That's the days she worked at the uh, restaurant. Okay. So remaining days are the days worked at, I'm sorry, it should be restaurant. We found the day she worked at the bookstore. So this is restaurant. Okay. So the days worked at the restaurant would be 19. Restaurant. If we calculate the days she worked at the bookstore, that was the 7 days. Questions, Maureen, on number 1?
No.
Okay. Read number 2. I think you can solve that one. Make it bigger so you can see it. Okay. Okay, Maureen, how would you solve number 2?
Okay. A club has 36 members. If each member donates 12 items in an auction, how many items will there be at the auction? You multiply 36 by 12.
That's it. What do you get?
432.
Okay. Okay. So multiply 12 by 36 is 432. Answer D. Okay. Just okay. So 12 by 36 because each member gives 12 items in that 36, and multiplication gives you the total. Right. Let's look at number 3. How would you solve number 3, Maureen?
Okay. What is the value of 410? That's 3 100s.
4 over 10 would be what over 100?
4 over 10
Yes, would be what
would
number
be
over 100?
40 over 100.
That's right. And so what's 40 over 100 plus 3 over 100?
7.
No, 4 over 10, and you're right, you said it's 40 over 100, right? So then when you add 40 over 100, 40 over 100 plus 3 over 100, just add the numerators. What's that equal to, Maureen?
43 over 100.
That's right. Very good. 43 over 100. So what would be the answer?
A.
That's it. Because remember, when you have the same denominator, you can add the numerators. So answer A. All right. So let me just make that bigger. Okay. All right. I think we're gonna stop here. We'll stop here,
Okay.
and I will say, um, okay. I'll just give you this one as homework, just number 4, and then we'll start on measurement on Monday. Okay.
You can send everything. Me say if I could get some done.
No,
If I have a time.
I'll send you the whole thing, but I'm just saying your homework is only
It's
gonna
only
be
number
number
4.
4, okay? But
Okay.
you feel free to do whatever you want because I have some
Yeah.
measurement problems.
Okay.
And so what I want you to do, and I'll just say homework number 4.
Okay.
Okay. So that's the homework. But you can feel free to do whatever you want of the measurement problems.
Yeah.
That's where we'll continue next time on the measurement problems. And I gave you the formulas for the ones like volume because you may have forgotten the, well, you actually it's on your measurement reference sheet. But so you don't have to look at it, I gave you like the volume of a cylinder.
Uh-huh.
Okay. All right, Maureen. So thank you for joining.
Yeah. Have a good weekend.
And you too. All right. See you on Monday. That will be
Monday.
our last
Okay.
session before the break.
I
Okay.
know. Uh-huh.
All right. So long.
Okay, so long. Mhm.